When we talk about the people who built our modern world, there's one name that stands above almost all others: Sir Isaac Newton. He wasn't just a key player in the scientific revolution, he literally gave us a new way to understand reality itself.
You know, this famous line from the poet Alexander Pope really says it all. It perfectly captures the massive impact Newton had. Before him, the universe felt like this vast, mysterious place. But after him, well, it became a system, a machine, governed by laws we could actually understand and describe with math.
So to really get a handle on his genius, we've got to go back in time. He was born in 1643, but his most important period of discovery came from a very unexpected place. When the Great Plague hit, Cambridge University had to shut down, and Newton was sent back home. And it was in that forced isolation that he had what we now call his golden years, just this absolute explosion of creativity that basically laid the groundwork for all of modern science.
All right, so how did he pull it all off? We're going to explore his work through 5 key areas, starting with where his ideas came from all the way to the legacy that, believe it or not, still shapes our world today.
First up, let's dive into the mind of the man himself, the mind that would kickstart a scientific revolution.
Newton's early life was, well, pretty solitary. He was all about intense, private study. But the real catalyst was the Great Plague. Being sent home from Cambridge wasn't a setback. It was the best thing that could have happened for science. In just about 2 years, he sketched out the fundamentals of calculus, figured out the secrets of light and color, and came up with his Law of Universal Gravitation. It was, without a doubt, one of the most productive couple of years in the entire history of human thought. Just incredible. Okay, so all of this groundbreaking work, where did it go? Well, it all came together in one single, massive book that would define physics for hundreds of years, the Principia Mathematica. And look, this was not just another science book. It was a complete, unified system for the cosmos. The Principia showed for the first time that the same exact laws that govern an apple falling from a tree also govern the planets moving through the heavens. It was a totally radical idea that swapped philosophical guesses for cold, hard, mathematical proof. At the very heart of it all are his 3 elegant laws of motion. First, you've got inertia. An object is going to keep doing what it's doing unless something messes with it. Second, the famous F equals ma, which connects force, mass, and acceleration. And third, for every single action, there's an equal and opposite reaction. These 3 simple rules explain the movement of everything. I mean, everything. But the real masterpiece, the thing that tied it all together, was his Law of Universal Gravitation. With this one beautiful equation, Newton proved that the force pulling that apple to the ground was the exact same force that holds the moon in orbit around the Earth. He had, in effect, unified the entire cosmos under one law. But think about it. To describe a universe that's constantly moving and changing, Newton had a huge problem. The math he had just wasn't good enough for the job. So what did he do? He invented a new one. He called it the method of fluxions, which of course we know as calculus. It was a language designed to talk about change, to describe things that are flowing, like velocity and acceleration. Honestly, without calculus, the physics in the Principia just wouldn't have been possible. And this leads us to one of the most famous rivalries in all of science. See, while Newton had developed calculus way earlier, he was really hesitant to publish his work. In the meantime, a German mathematician, Gottfried Wilhelm Leibniz, developed his own version completely independently, and he published it first. The dispute got pretty nasty, but today we credit them both as co-inventors. Though, funnily enough, it's Leibniz's more user-friendly notation that we all use today. But Newton wasn't just some theorist scribbling equations. Nope, he was also a meticulous and, frankly, brilliant experimentalist, especially when it came to the mystery of light and color. Before Newton, nobody really knew. Seriously, is color a property of the object itself, or is it something in the light that shines on it? Newton decided he was going to figure this out with a series of incredibly clever experiments. His experimentum crucius, or crucial experiment, was just a masterpiece of scientific logic. He'd use one prism to break sunlight into a rainbow. Then, and this is the genius part, he'd use a second prism to show that a single color, like red, couldn't be broken down any further. And then, to seal the deal, he used another prism to put all the colors back together again, recombining them into pure white light. He proved that white light isn't pure at all. It's actually a mix of all the colors. And this discovery had immediate practical results. Newton realized that lenses bend different colors of light at slightly different angles, a problem called chromatic aberration, which makes telescope images fuzzy. So he designed and built the world's first working reflecting telescope. By using a mirror instead of a lens, he completely sidestepped the problem and created a much sharper, clearer way to look at the stars. So when you add it all up, Newton's legacy isn't just a list of things he found, it's a whole new way of thinking. He literally gave us the blueprint for how science should be done. Right there in the Principia, he lays out these 4 rules for reasoning. Basically, keep your explanations simple, assume the laws of nature are the same everywhere, and, most importantly, what you learn from experiments should be considered true until another experiment proves it wrong. This is the bedrock of the modern scientific method.
He summed up his entire philosophy with this one famous Latin phrase, hypotheses non fingo. What did he mean by that? He meant I don't do guesswork. For instance, he could describe gravity perfectly with math, but he refused to guess why it existed because he couldn't prove it with experiments. For Newton, science had to be built on a foundation of evidence and math, not on philosophical ideas you couldn't actually test. And yet, just when you think you've got this guy pegged as the ultimate rationalist, you take a look at his personal library, and it's a shock. The vast majority of his books weren't about math or physics. They were about theology and alchemy. Now, back then, the lines between science and magic were, well, they were blurry. Newton saw it all as part of the same grand quest, to understand the divine mind of God by studying his creation. This complexity is what led the famous economist John Maynard Keynes, who went through Newton's private papers, to this really profound conclusion. Keynes realized that Newton wasn't the first modern man. He was the last of the ancient magicians, searching for cosmic secrets. And that right there is the enduring puzzle of Isaac Newton. How do we square these two sides of the same person? On one hand, you have the rational genius who built modern science. On the other, a mystic obsessed with alchemy and prophecy. Figuring that out is the key to understanding not just the man, but the very moment our modern world was born.